Hello everyone, I'm Andrew McCleary from Wham Bam Systems, and I'm here to show you how easy it is to add a simple laser to your 3D printer using a Wham Bam Mutant tool swapping system. Using a Wham Bam tool swapping system opens up a whole new world for 3D printers. One of those worlds is the ability to quickly swap out your hot end with a diode laser to do simple laser engraving projects and then swap right back. Setting up a laser on a Mutant is a pretty easy procedure and adds a whole new tool to your toolbox. In this video, we're going to show you how you can get your feet wet in the world of laser engraving without a lot of investment. We're going to use a simple, low-power, inexpensive laser and open source software that you can get into lasering with your Mutant on your 3D printer with a minimum investment of probably less than $60. With a simple laser and open source software, I think you're going to be really amazed at the creative things that you can do. For this tutorial, I'm using a 500 milliwatt or half-watt blue-violet laser engraving head. These are easily available from both Creality, Amazon, and many other sources. Ours is a simple 12/24 volt laser from Creality that's suitable for doing simple engraving on a number of materials such as wood, leather, acrylic, paper, and many other materials. It can easily cut a number of craft materials such as EVA foam and construction paper. It's also very easy to hook up to most 3D printers without having to do any modifications if you have a Mutant. Some of these half-watt lasers show using magnets to mount it to your hot end, which can be very dangerous. But by mounting this laser with a Mutant, not only is the laser mounted firmly, but also all of your electrical connections are taken care of easily and allow you to quickly swap back to your 3D printing hot end. For software, we're going to be using the open source drawing program Inkscape. It's available for both Mac and PC, and there are extensions that have been written to output your vector art as G-code specifically for use with a laser. In this tutorial, we're going to be using the cooling fan connections, which should already be wired up for use in your hot end to your Mutant fixed plate. We're going to be keeping things as simple as possible. We're going to show you a setup that doesn't require any additional wiring or modifications of your printer's firmware. Just put your laser on the Mutant mobile plate and swap it in. There are a number of really cool, much higher power lasers out there that can mount the Mutant, and commercially available software that allows us to do much more advanced laser etching techniques such as grayscale and photos. We have this 40-watt NIJI laser that we've been working with in our lab that can even cut 20mm thick wood. This gets a little more involved than we're going to be getting into this tutorial, so we're going to leave it for another tutorial. Likewise, Inkscape is a great way to get a taste of what a laser can do, but it has some limitations, such as only being able to do vector art. If you're interested in seeing a more advanced tutorial using the NIJI laser and commercial software such as Lightburn, leave your comments in the comment area. Oh, and be sure to like and subscribe to the Wham Bam channel. What I can say is that I was delightfully surprised at how incredibly useful even a simple low-power laser and using free open software was to add a great new tool to my toolbox. Before we go on, we need to get some important things out of the way before we start having fun. Lasers, even these inexpensive low-powered ones, are extremely dangerous to your eyes. Do not turn one on without wearing appropriate protective glasses. I can't really stress this enough. All it takes is one moment of the laser reflecting off something into your eye to do permanent damage and cause blindness. While the beam may not be strong enough to burn at a longer distance, it is strong enough to do damage to your nerves in your eyes and the lenses of your eyes. You must also be aware of pets and children in the area who may inadvertently look at the laser. So be safe with your eyes. Using a laser actually means you're burning material. While we're using a pretty low power laser in this tutorial, it will start a fire. I like to keep a small squirt bottle around, as well as you should keep a fully approved fire extinguisher nearby. When using your laser, you also want to be present and keep an eye on it when it's in operation. This is especially true when working with any new materials that you haven't tested before. Fumes are also another thing you want to consider. If you don't have some kind of vacuum system to exhaust the fumes, then lasering should be done in a very well ventilated area. Some materials shouldn't be lasered at all because of the highly toxic fumes they can give off, or that they just don't laser well. This includes PVC, Lexan, ABS, HDPE, and fiberglass, as well as many others. If you're in doubt, Google the material you want to laser. I'm also going to put a good link to some resources in the description. In this tutorial, I'm going to show you how to put some artwork on this cheese board that I'll make a really cool gift for my friend's restaurant. So let's get started setting up our laser. The first step is to mount your laser to your MUTANT mobile plate. The MUTANT has a number of holes and slots that make this part really easy. In the case of the Creality laser, it already has threaded holes in the back that were holding the magnets. These will line up with the slots in the MUTANT mobile plate. The laser mounts to the MUTANT mobile plate via two 4mm bolts from the back. Line up the laser so that it's straight and as far down as you can on the plate. The Creality laser has a lens that can be tuned to focus the beam, so it doesn't have to be exact. If your laser has a fixed focus, some are 30mm, you may want to adjust it up or down in the slots to get it as close to possible to line up with the home and build plate at that dimension. On most Creality printers, it's about 26mm from the base of the MUTANT mobile plate to the build plate. The power for this low power laser can be connected directly to the connections used by the part's cooling fan. This isn't true for all lasers. Some lasers may have higher amperage than can be handled through the part's cooling fan. Be sure to check that you have either 12 volts or 24 volts available to this connection when the part's cooling fan is turned on. The CR10V2 we are using is a 24 volt system, so this one works great. Be sure to check with your printer's specifications so you know what the operating voltage is. There are ways to hook up a 12 volt laser to a 24 volt printer, but this is something we're going to cover in a more advanced laser tutorial. Identify and confirm which connections you're using for your part's cooling fan. If you're using the wiring standard suggested by Wham Bam, then your wiring looks like the following, and you want to use terminals G and H. Be very careful to confirm polarity. On many 3D printers, the firmware will throw an error if the thermistor is missing. The easiest way to solve this is to wire in an extra thermistor. You want to wire the thermistor into the terminals that are used by your hot end thermistor. If you're using our standards, this is C and D. Now that you have your laser mounted on a MUTANT mobile plate, it's really easy to swap out your hot end and put on the laser. If you have one of our magnetic flexi-plate systems, it's also a good idea to flip it over to the bare metal facing up. This way, your laser won't hurt your build surface. The metal will protect your build surface, but you don't want to use the laser on a flat metal because it will reflect the laser back up into itself, potentially causing it to burn out. It can also reflect into someone's eyes. You want to put on what we call in the industry a spoil board. This is a surface that we can burn into and not worry about, and it's easy to replace once it gets too many marks on it. I bought this 1/4 inch thick 1 foot square piece of MDF from the hardware store for this purpose. Make sure you put your spoil board on the build surface. I had to cut out a small corner of this board so that my printer would home properly without the wheel of the X gantry hitting the spoil board. You need to check your printer and see if yours will clear. Now it's time to test out the laser and focus it. To do this, go to the menu on your printer and home your printer. Then move the Z to 20 so it will go over the spoil board. Then the X to 100 and the Y to 100 so the laser is out over the spoil board. I'm using Marlin for my firmware, so your menu might look slightly different. Now it's time to put on your laser safety glasses before continuing. Keep them on for all the next steps. The laser's power is controlled by the part's cooling fan setting. So to turn on the laser for testing, we're going to go into the menu and turn on the cooling fan. We're going to set it to 100%. When you turn on the laser, the beam will probably make a small oval-shaped or rice-shaped blue dot on the board. You're going to use your fingers to carefully tune the focus adjustment ring until the laser point is a tiny round dot and you start to see smoke rising off the wood. The wood will turn to a black carbon at this point, and then the smoke will stop rising. Move the wood a bit and it will burn another small dot. If it doesn't, adjust the beam till you get the dot as small as possible, and moving the wood very slowly will burn a line as you move the wood. Once you have it set up to a nice point that will burn, turn off the laser in the menu by setting the cooling fan back to 0. Only when this is done is it safe to take off your laser safety goggles. Now we are going to measure the distance from the wood to the edge of the laser housing. Write this measurement down. This is the measurement we're going to need to set the height of the laser as we put other items under the bed for it being etched. In my example, it's 33 millimeters. Another way is to create a measuring stick with a mark on it. You can easily use this to quickly set your laser's height. Our mutant and our laser are all set up. Now that the laser is set up, we need to install some software to be able to output some G-code to make some cool things. This software works very similar to your slicer software, except it's 2D and it outputs G-code to move the laser and turn it on and off. For this tutorial, we're going to use a free software called Inkscape and an extension created by Photonics. Using this combination gives you basic vector etching and cutting capabilities. Let's start by installing version 1.1 of Inkscape. You can download versions for both the Mac or the PC from the link you see on the screen. I will also put all the links in the description. Let's start by downloading Inkscape. Just select the operating system that you're going to use and download the software. Now it's time to install Inkscape on your computer. This is a standard install process on both a Mac and PC. This part is pretty straightforward. The next step is to download the Inkscape extension from Photonics. The links in the page are shown on the screen. They'll also be in the description below. You want to make sure you have the correct one for the version of Inkscape you're using. Because we're using version 1.1, I'm going to be using the beta Inkscape for version 1. All you do is simply click and download and put that in the same spot. The install of the extensions in Inkscape is a bit different depending on if you're using a Mac or a PC, and it isn't quite as easy as using a pre-packed installation wizard, so I'm going to walk you through the steps. Here's how you do it on the Mac. Start by downloading and extracting the files from the zip file. There should be two files, a laser PY and a laser INX. We're going to select these and we're going to copy them. The next step is using your Finder, go to the Applications directory and find Inkscape. Got a lot of things here, so there it is, Inkscape. And what I want to do is, holding down the Control key, we're going to select and we're going to show package contents. At this point, we're going to want to show resources, share, Inkscape, extensions. And then we're going to come over here, I'm going to scroll to the bottom of this, and we're going to paste those two files that we copied into this directory. Let's go and check and make sure that they're there. There they are, right there. That's all there is for installing the extension. The next step is to open up Inkscape, say New Document. The first thing we want to do is go up to the extensions and check that our extension is there. You should have under Extensions, Generate Laser G-Code, Photonics Laser Tool. Now that that tool's there, the first part is to set up our first document. We want to make sure that the document is set up appropriately so that it will match our printer. Now that we have a new document, we want to set it all up so that it will display properly. We want to start by making sure that the display units are millimeters. And the next step is to set the height and width of our building area. In our case, it's 300 by 300. And we want to make sure that, again, the units here are set to millimeters. Once we have that set up, we'll have our document ready to add some artwork. Our first step is to bring the artwork into Inkscape. And I open up my file. From here, I'm going to want to select everything. and we're going to copy, and then we're going to paste it into that new document where we have everything set up properly. And scale it to the size that we want. While we're in here, we want to again look at our fill and stroke, make sure that all the fills are turned off, and our strokes are all just set to black. Your stroke style you can set to any width you want. It's really not used, but I usually set it to something very low so that I know and can quickly see if I've got any issues. I'm going to show you a quick trick for being able to line up your graphics to the part we're going to laser. We're going to start by taking a ruler and measuring out around the outside of our item. The next thing we want to do is we want to create an outline of the object that we're going to put it on. We'll use this to help register our artwork on our object. In this case, I know that the cheese board that we're going to be putting this on is 250. Put that in. 250 wide by 330 high. Now this is going to go off of our build plate some, but that's okay. What I want to do is get it centered on here where I know my artwork is going to be correct. I'm going to center it from the bottom, so I'm going to use the bottom of my build plate as the bottom of my frame. Now I'm going to come back in here and select my artwork again, and I'm going to make sure that it's positioned and centered within that box. If you do have to group everything together again to move it around, make sure that you ungroup it, because if anything is grouped, you're going to have a problem when you use the extension. In fact, I'm even going to come here and ungroup. There we go. Everything is ungrouped. Once we have our outline and everything set up, I'm going to come up and say File, Save As, and we're going to save this as cheeseboard.svg. Then what I want to do is I want to select the inside artwork and delete it, and then do File, Save As, and we're going to call this cheeseboard outline.svg. Now we come back and open up our original file. And in this file, we're going to select the outline, and we're going to delete it and save it again. So now we have two files, one with the outline and one without the outline. We select everything and make sure that everything is ungrouped. If everything's ungrouped, we're pretty much ready to go. If you did have any elements in here that were not paths, then you'd also have to want to go up to Object, or up to Path, Stroke to Path. But all of these elements were paths. I was to create them all into paths. Then we go up to our extension, Generate. We make sure our commands are there. We want to change our laser speed to 300, our power to 200, one pass. In this case, we're going to give it the file name, cheeseboardartwork.gcode. It's millimeters, and we hit apply. It's going to now go out and begin creating the G code. It can take a little bit of time. If it does throw an error in this process, it's usually because you had something that was still grouped together. If that's the case, what you're going to want to do is let it continue and then go through and look on the screen and look and see if there's any places where the arrows that it puts over the top are not there. That's probably the element was grouped. You might also find that that element is actually had the arrows, but it was off to the side. Again, it's probably because it was grouped. and it couldn't figure out how to do it properly. In this case, everything looks like it came out just the way we wanted. You can see all of our artwork is covered with the little arrows that the extension produces, and that our 0, point is in the appropriate spot. We can then open up Finder and go to the place where we put it. I can open with, Other, Text Edit. By opening up the G-code in my text editor, I can see all the G-code is there. If I wanted to add any other G-code into this, this would be the time that I can do it. One other thing to note, if you look at this, you'll notice that all of our G-code commands only involve X and Y coordinates. There are no Z coordinates in this G-code. This is great, because what this means is that you can put your object underneath there, move your Z height to where you want it to be, which I'll show you in a moment, and then when you're running this G-code, it's not going to move your Z height. Our last step is we want to go back to our cheeseboard outline.svg, and we want to output this as G-code. One thing you're going to want to do is you're going to want to select the box that we created, and you're going to want to come up to Path, Stroke to Path, and then Extension. We generate our G-code tool, and we're going to want to call this cheeseboard outline.gcode. And there we go. You notice that we get our arrows going around there, so our G-code is outputted, and we're ready to go. We're now ready to send these files over to the laser. Let's start by opening up our outline G-code file. What we're going to do is burn our outline into our spoil board so that we know where to line up our cheese board. We have this outline, it's going to be easy to line up our artwork. Before we start lasering, we need to set up the laser for the added height of the board or the object we're working with. We want to do this before we put our object in place. Use the menu on your printer to home the printer. Now, using your menu controls, move the laser up and over the block of wood using your Z movement on your screen. You want to start about 20 millimeters above your object. Now, place your object on the spoil board. For lighter objects, you can use a bit of double stick tape to hold it in place. Use the measurement stick that we made before when we were setting up the laser. Use your menu controls to adjust the Z height so that it matches the same measurement from the top of the object, in this case my cheese board, and the spot on the laser house we measured. We're all set. Time for the fun to begin. Be sure to put on your safety glasses again. Now we load and run our G-code for our graphic. This simple laser is a great tool for doing a lot of that we couldn't do with our 3D printer before. Because it's so quick and easy to put on with the MUTANT setup, it's easy to make a lot of things that you might not have been able to before. You can put a graphic on leather. You can cut out EVA foam to use as inlays into your 3D prints, or for scrapbooking or other cool projects. Quickly add a logo to some cork for a 3D printed coaster. There are tons of ways that you can use a laser to enhance the items you're 3D printing or open up whole new ways to make gifts or products. We really hope you enjoyed this tutorial. I hope we've sparked your imagination and some of the possibilities that a laser combined with a Wham Bam Mutant opens up. If you enjoyed this video, hit the like button and subscribe. If you'd like to see another video and more advanced laser setups, please leave some comments below. Thank you all for your time, and goodbye until next time.